and rotating it around, you can look at it either as the way it is. I think it's best just to draw the picture of the cross-sectional area and then try and figure out what the two radii are, right? The outside radii, whether you move everything up by one to make the axis the x-axis, which you can do, right? You could take the whole thing and move it up one, which is going to mean all of these things are moving, right? If you move this entire thing up, it just makes it so that the axis you're rotating it around is on the x-axis, and some people find that easier. Regardless of that, the inside radius here is 1, and the outside radius is x squared plus 1. So if you write the expression for that cross-sectional area, again, if you have two circles, it's pi times the outside radius squared minus pi times the inside radius squared. That's the area. So in this case, we have pi times x squared plus 1 squared minus pi times 1 squared. That's the area. The volume is going to be the integral from 0 to 2 of that area. You can put the pi outside if you'd rather here. X squared plus 1 squared minus 1 squared. We'll put squared just to keep track of it. Dx. Whether you do that on the calculator or exact value, up to you. Okay. And it was 36.86 or what is it? 176 pi over 15. Or approximately 36.86. All right. So you have washers or discs, depending on whether there's a hole in the center or not. This would be no different if this was a function rather than I guess 1 is a function, but or 0 here is a function. If this wasn't just a straight line, if this was like that or something, it's the same. It's just going to mean that this is going to be a function rather than a constant value there. Yep.
If you don't include x equals 0, then how do you have a left boundary? Because the function does keep going away.
Well, I guess that what I was thinking originally was, let's make this thicker so we can see what I'm talking about here. I was thinking of just saying that line, this line, and this line, because all three of them intersect and it makes a closed space.
Oh, right.
Because it touches over there. This other question here, if this was, the reason I put this in here, if it was rotated around y equals 4, if this went around y equals 4, it's up here, and I think it's actually where this intersects, right? It should be. Now, my thing's not drawn properly, but if it was rotated around that, the washers would be up here, right? And this now would be the outside radius. You just have to think about where you're rotating it around. This is going to mean that this is this is what they look like. I don't know why I'm doing that when we have the technology. If you change the axis you're rotating this around to positive 4 here. It's not going to fit on the screen. We'll have to change the boundaries. So it just means that that's now the outside radius. I guess I could do even more than that. Okay, so this is going to create the same kind of thing here, except that the outside radius is constant, the inside radius changes now. So where the axis is changes it, and it looks, as long as you can kind of draw a picture and visualize what the cross-section looks like, this is very easy. I really encourage you to try and, you still have some holdover of your habits from grade 8. Grade 8s don't like to do any intermediate kind of work. They like to just try and go right to the final answer without doing any work. That's their goal, actually, is to write as little as possible. And it really helps, I think, to draw something like this, or at least draw it on the picture so that you can try and set up the expressions. Okay? Working on any more of these right now, I don't know if it's going to add anything to it. Coming back to it later certainly would. We're going to look at the last section here, which is very much related to this.